Hi everyone. How can you write an equation for a line? There are many different ways. For example, here's general form. For example, 2x plus 3y equals 4. Here's the graph of 2x plus 3y equals 4. It's a tilted line. If just one of these coefficients is 0, you get a horizontal or a vertical line. If both of these are 0, you don't have a line. Now I have a question for you. If I have a line and you care, what are a couple of hints I could give you so that you can figure out the equation of the line in the xy plane? If I give you a what on the line, and if I give you the what of the line, what pair of bits of information? Well, maybe if I give you a point on the line, any point on the line, and if I give you the slope, I'm assuming the slope is undefined. I'm assuming that the slope is defined. If the slope is undefined, you know that you have a vertical line, in which case you can figure out the equation anyway. It's the equation of a vertical line. But let's assume that we have a tilted line and the slope is defined and not 0. Point slope form. What is the point slope form for the equation of a line? Let's say that x sub 1 comma y sub 1 is a point on the line, and m is the slope. In fact, m could even be 0, but let's assume for now that m is not 0. M is defined. Now notice that if you were to divide both sides of this by x minus x sub 1, then you would get that the slope looks like this kind of difference quotient here, change in y over change in x. So basically, we want all points x comma y that will force this constant ratio as a slope. So you have a point, you connect it with the key point x sub 1 comma y sub 1. You want all points x comma y that will force a slope m with this given point, x1, y1. So that is point slope form. Y minus y sub 1 equals m times the quantity x minus x sub 1. Point slope form for a line, where m is defined. Now, if we have a slanted line that does not go through the origin, what are the two most important points on that line? Many people would say. Well, quite possibly the x-intercept and the y-intercept. If I give you the y-intercept and the slope, then you're in business. You can find the equation of the line. All right, slope-intercept form, where we use the y-intercept. Slope-intercept form, y equals mx plus b, where the ordered pair, 0 comma b, technically, is the y-intercept. Y equals mx plus b. So for example, let's consider y equals 2x plus 3. Okay, y equals 2x, that has slope 2, but it goes to the origin, 0 comma 0. Y equals 2x plus 3, that goes to the point 0 comma 3 as the y-intercept. If I have y equals 2x plus 4, then it goes through 0 comma 4 as the y-intercept, and so forth. I could put a slider here, 0 comma b. Put a slider here. If I slide b, then I change the y-intercept. I can put in an m slider over here. Y equals mx plus b. I have two sliders. One slider for slope, one slider that affects the y-intercept. Together, I can get all possible non-vertical lines. Y equals mx plus b. If you have a big old slider for m, big old slider for b, you can get all possible non-vertical lines in the xy plane. We have two parameters for this slope-intercept form for the equation of a line. The slope m and the y-intercept given by b, or 0 comma b. Here's a more exotic form, two-intercept form. Again, if you take a line like 2x plus 3y equals 4, a slanted or tilted line that does not go through the origin will have an x-intercept and a y-intercept that are distinct and not at the origin. Okay, well, if a comma 0 is the x-intercept, and if 0 comma b is the y-intercept, here's another form. Observe that a comma 0, the x-intercept, satisfies this equation. 0 comma b would also satisfy this equation if b is not 0. It's a bit exotic, but it's there. Two-intercept form for a tilted line that does not go through the origin. Next up, the classic problem. Given two distinct points, and they're going to determine a line in the xy plane, find an equation for such a line. There's only one line that can do it, but there are different forms. Let's find different forms for the equation of the line, for an equation of the line that goes through these two distinct points in the xy plane. Next time.